4.5 billion years ago, the Earth's formation culminated in a cataclysm. A planetary embryo the size of Mars slammed into the proto-Earth. The kinetic energy from that collision generated enough heat to liquefy the planet's outer layer, wrapping the globe in an ocean of churning magma. For decades, geologists looked at that violent origin, along with the constant meteorite bombardment of the era, and concluded that Earth was completely uninhabitable for its first 500 million years. They pictured a molten purgatory so relentlessly hostile that they officially named this geological eon the Hadean, a direct reference to the Greek underworld. That fiery vision of early Earth has dominated textbooks for generations, but modern physical evidence tells a completely different story. The proof comes from microscopic slivers of the past. Tiny mineral grains called Hadean zircons are the only surviving physical material from Earth's first 500 million years. Zircons are incredibly resilient. When Earth's crust undergoes extreme melting, surrounding rocks liquefy, but the crystal remains intact. Researchers examining 4-billion-year-old Australian zircons expected extensive damage. Instead, they found perfectly ordered interior lattices, completely lacking shock metamorphism. Shock metamorphism is the distinct crystallographic scarring left behind by massive, violent asteroid impacts. A heavily bombarded environment should have left these microscopic time capsules shattered and warped, yet they are pristine. The absence of impact scars on these ancient crystals shows that their local surface environment was surprisingly solid and stable. This physical evidence forces us to abandon the assumption of a global, continuous magma ocean. The chemical composition locked inside these crystals acts as a precise thermometer for the ancient Earth. By analyzing heavy oxygen isotopes trapped within the crystal, researchers determine its original environment. Graphed data shows Hadean zircons crossing a distinct threshold. This heavy oxygen signature only occurs when rock interacts directly with liquid water at low temperatures. You cannot have liquid surface water on a planet covered in churning lava. The chemistry makes a continuous 500 million-year magma ocean physically impossible. Instead, this water-rock interaction facilitated the creation of early felsic rock, specifically the granitoid crusts that make up solid continents. The data also indicates that these rocks were pushed and pulled in low-temperature plate boundary interactions, operating much like modern tectonic subduction zones. The chemical record proves that the hellscape rapidly cooled, forming solid continents and massive oceans of liquid water, mere hundreds of millions of years after the planet formed. If we zoom out to a global view of the Hadean Earth based on new data, the volcanic imagery is replaced by vast, deep oceans, heavy cloud cover, and small, dark land masses. Furthermore, a process known as ejectoweathering might have made early Earth quite cold. As impact debris from meteorites chemically weathered on the surface, it would have pulled large amounts of carbon dioxide directly out of the atmosphere. Removing that greenhouse gas would have dramatically cooled the planet, potentially resulting in a cold surface environment and an ocean with a basic, alkaline pH. The Hadean was likely a cold, alkaline water world that looked strikingly similar to the Earth we inhabit today. The conformation of stable crusts and liquid oceans forces us to rethink the ultimate biological question: when did life begin? Deep inside some of these ancient zircons, scientists have found graphitic inclusions, forms of carbon, that suggest a potential biosphere might have existed as early as 4.1 billion years ago. Modern academic literature no longer assumes the planet was too hostile for biology. Instead, researchers are actively debating how early microbial life might have survived the late heavy bombardment. Earth was born an oasis, setting the stage for life from the very beginning. Because stable oceans emerged almost immediately after its violent birth, biology did not have to wait billions of years for the planet to become habitable.